Well, good afternoon, good evening, or good morning, depending upon where you are in this world, and welcome to today's DEVOPS.com webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. We have a great webinar on tap, but before we get started, I just want to remind the audience that today's event is being recorded. So if you miss any or all of the event, you'll be able to access it on demand. We'll be sending out an email post-event that will include a link to take you to the event online, on demand. Okay, with that, we'll go ahead and get started with today's webinar, which is OPENSHIFT-CONJUR webinar. Our speakers today, we have two really great, I'm laughing because I just love the mustache on one of our speakers. We have Jason Dobies, who is the Partner Technical Marketing Engineer for OpenShift Ecosystem at Red Hat, and Joe Garcia, Global Corporate Solutions Engineer at CyberArk. Welcome, gentlemen. Thank you both for joining me today. All right,
Great.
Jason, I know that you are speaking first, so go ahead and you do your thing, and I'll just put myself on mute for you.
Great, thank you very much. So as she said, this is Jason Dobies from the Red Hat side of things. I would normally start a talk like this talking about what is DevOps or do some kind of introduction to that, but given the audience, we're going to skip a bit of that. But I do want to talk about containers. Often these days you hear containers as being billed as anything from a single piece to the be-all, end-all to how you enable DevOps. So I really want to just do a quick sanity check to bring everyone up to speed on how we perceive containers and what they are. And ultimately, it actually depends on what view you're taking on it or who you're asking. Strictly speaking, from the infrastructure standpoint, the very technical breakdown, this is a application process. They are sandboxed away from each other so they can run multi-tenant environments. At the end of the day, they are a much lighter version of virtual machines. It gets us the portability we've looked for. It gets us the isolation we were looking for without the added layer of the hypervisor and the extra resource allocation. So instead of talking in terms of a couple of dozen virtual machines, we're now talking at scales of a couple of thousand containers being able to run on a host. So that's the infrastructure view on things. From the application side, it's much more of a packaging mechanism. This is how we can take all of our dependencies, keep them co-located and isolated enough where any host dependencies or the dependencies for other applications aren't going to interfere. It's a much simpler way of running, for instance, different versions of Python, Python 2 versus Python 3, instead of having to jump through the hoops on a single host machine, or instead of having to run to somewhat heavier weight virtual machines. From the application standpoint, all of that is packaged inside of our container, which makes things more consistent as we go from environment to environment. Makes it simpler to share them between different machines and different data centers, and it also gives us the benefit of knowing exactly what's in every container at runtime. We don't necessarily have to be cognizant of what may or may not be running on the host. Next slide, please. So what does our DevOps picture look like when we bring containers into the mix? The left side of the beginning of the flow is fairly standard. We still have our developers using a source code repository. We still very likely have a CI/CD engine in play. Again, given this audience, I'm assuming virtually everyone here is familiar with the concepts of CI/CD, very likely starting to implement them into your practices if they're not already a completely first-class citizen. The difference is what comes out of those. Now the CI/CD engine is going to produce for us a container image. That gets put in some kind of container repository. Commonly, we use something public like Docker Hub or Quay.io, but there are other options for hosting your own internal container repository. From there, it gets deployed to any number of different environments. I like the right side of the slide. It's extremely cliche in the, hey, you can deploy anywhere. But at the end of the day, that's what we're looking at. It can be deployed on a bare metal machine that has nothing but a lightweight container runtime on it. It can deploy inside of virtual machines that are optimized to run containers and have the runtime. And then obviously at that point, we can extend it to public cloud, private cloud, and then obviously hybrid cloud as well. Next slide, please. So what does that actually look like though? We produced an image and we want to get it out to our data centers. And on the surface, it sounds like great. We just drop it out there and our container is running in any one of those environments I just mentioned. The reality of the situation is a bit different. Next slide. You don't usually produce a single container. Most applications these days are being decomposed into what are called microservices. And the idea being that any application is going to have anywhere from a handful to a few dozen different containers, all interacting with each other with fairly complex networking requirements, fairly complex visibility and routing to what can be accessed from the public internet. And then how do you actually get that across multiple data centers? You don't want to be manually saying, I'm going to deploy this to New York, now I'm going to deploy it to San Francisco, now I'm going to deploy it to Tokyo. So everything I mentioned at the beginning is very cool in concept. These all make sense as a theory. The reality of the situation is a little bit more complex. Next slide. So at the end of the day, it's not just enough to have containers. They are a piece, but simply saying, I've taken my application, dropped it in a container, therefore I'm DevOps, I'm cloud native, I'm all of the fancy buzzwords, you're not there yet. There's a lot more that needs to be taken into consideration. The scheduling is a major piece for container deployments. If you're looking at multiple containers and their interaction, you need to be able to understand and visualize where they're getting deployed over the various data centers. Jumping around a bit on this slide, scaling is similarly complicated. That if I have this container out there and it's hosting X amount of workload, I need to be able to scale that independently from the other containers, but also understand which of these services need to be scaled, both up and down. Once we're past a particular high traffic situation for whatever reason, we need to be able to reallocate those resources and scale back our services. We need monitoring. This becomes even more important, in my opinion, in this containerized world where our application is broken up across multiple processes, multiple data centers. How do I visualize and how do I understand the full breadth of my application and where it's running? And most importantly, is it running and how is it performing? And do I need to allocate resources, or am I having some kind of errors where my container is repeatedly crashing and being restarted? Persistence is obviously still important as well. The 12-factor app likes to talk about stateless applications, but at the end of the day, everybody has data. So we need to be able to store persistent data outside of the container, so that way we retain the portability of our container, but we don't lose the actual important data in the process. And then security, that was one of the easier sells because at the end of the day, security is always going to be a concern. In a pre-containerized world, in a containerized world, whatever comes next, we're always going to have this underlying issue of security, be it what services can access each other, how do we secure our data, how do we keep an eye on our running containers and those images to understand if there's been a new exploit or if there's a new release that we need to make. Next slide, please. So on top of containers, orchestration engines have started to crop up as a way of handling some of these concerns. Kubernetes is the leader in this space right now. It is an open source orchestration engine that handles a lot of the things I mentioned on the previous slide. Easiest way to think about it, or I guess the first way everybody thinks about it, is as a scheduler. I tell Kubernetes I need to get X many containers of this image deployed, and I let Kubernetes take care of deploying it across all of its configured data centers. Next slide, please. So now our picture from before. We have this complicated end state of various network interactions and policies, various geographic distributions, or certain hardware needs. For instance, if we want GPUs available to our containers, we let Kubernetes handle that for us. So we have our application composed of multiple containers. We run through Kubernetes as our orchestration engine, and it can paint this picture on the right for us and all of its complicated interactions. Next slide. So going back to our earlier image here, we still have our CI/CD engine. We run it through Kubernetes instead, and poof, now our containers are deployed on the data center. Next slide. Unfortunately, that's not quite enough in and of itself. Much like containers weren't enough on their own, Kubernetes isn't quite enough on its own as well. We need much more robust networking controls than Kubernetes supports, both east-west traffic as well as ingress and egress controls to be able to safely lock down our services and ensure that they're able to communicate efficiently, not introduce a ton of lag or network loss that's going to impact our service. Next slide. We may need our own image registry. Yes, Docker Hub and Quay.io are popular public alternatives, but at the end of the day, our applications, we may want more security. We may want to lock down those images or not make them accessible. We may want to have an on-site image registry for performance concerns. If we're going to be readily scaling our containers, we're going to need quick access to that image registry and not have to rely on things running in Docker Hub, or I should say running in an environment that we don't control. Next slide. We need metrics and logging. We also need the visibility into our application. We need to pull in outside monitoring applications, be it CNCF-based projects like Prometheus or third-party vendors who have specialized in monitoring applications and are starting to adapt to how do you monitor cloud-native container-based applications, and how do you safely and seamlessly plug that into the platform so we can utilize everything we have in the past, our previous integrations, our previous alerting and notification setups, but in our new containerized world. So we need those APIs. We need that ability to adapt those systems and those solutions into our platform. Next slide. Still not quite enough. We need deployment and upgrade automation. These become more and more complicated when you have to scale, when you have to update multiple containers concurrently, or how do you handle an upgrade where you want to run a blue-green deployment that starts to upgrade certain containers and leave others alone? How do we handle the network access across the two different deployments? And we start to bring things up while having zero downtime and not taking our entire application offline while we recreate all of the containers. We need the platforms to facilitate for us. That's not something we want to manually be doing. Next slide. We need application lifecycle management. One of the benefits of containers is their portability, is how much of the environment is encapsulated within. So we also need to be able to pass those around easily between development, QA, and production. And to take advantage of that, to be able to really utilize what containers get us in that full-blown environment, doesn't get us much if we can't promote the exact same image through our different environments. Next slide. We need application services on top of what we're writing. At the end of the day, we still need databases. We still need message queues. We still need web servers. We need access to trusted images running these services that we can deploy in our platform, understand where they came from, who initially wrote those, without having to write them ourselves or perform the due diligence to understand these images are safe to run in our production level environment. So on top of the ability that the platform gives us for dealing with our applications, we need it to come packaged in with application services for us. Next slide. Part of the DevOps move and part of the benefits of containers is that this puts a lot more power in the hands of the developers starting to write these applications. So if a developer needs access to a particular environment so they can start prototyping something or begin work down a proof of concept, we don't want them to be submitting a ticket that's going to take multiple days for an IT operations department to field. We need a self-service portal on top of all of this with the ability to control things like resource quotas and permissions, but also enabling developers what they need to get access to these environments so they can do their job without having to go through any kind of manual intervention or some kind of separate team. Next slide. So instead, the next level up. Kubernetes was a level on top of containers in that it enabled them to do more flexible and more powerful things. OpenShift is built on top of Kubernetes and layers in everything we saw in the past handful of slides. It takes Kubernetes, does the Red Hat thing to it, makes it enterprise ready, and adds a number of development and production level tools in order to facilitate the entire workflow of how we start with containers and the idea of a containerized cloud native application and actually drive it all the way through to production. Next slide. So with that,
That's it, Jason. It looks like it's.
Yeah, I was going to transition to you. So with that as the introduction to a brief overview of what OpenShift is looking to accomplish and the different areas that need to be taken into account, I'm going to hand it over to Joe, and he's going to talk a little bit more specifically about CyberArk and our integration with them.
Thanks, Jason. So you could tell I was kind of eager to get started there for a second, huh? Sorry about that, but thank you everybody for joining us. I know that a lot of you who have been working in the security realm for a little bit may understand who CyberArk is from that area. However, to the entire realm of people utilizing the DevOps methodology, we may be a newcomer to this space. And so we're going to talk a little bit quickly about CyberArk at a very high level and what we're trying to provide to companies that are starting to explore DevOps and the world of pipelines, etc. So first and foremost, we are the market leader in privileged access security. We definitely try to protect the heart of the enterprise against advanced cyber attacks. We are the second largest Israeli cybersecurity company in the world, and we have been proven successful over the 15+ years we've been in business by utilizing continuous innovation and providing award-winning enterprise class solutions. So we're very uniquely positioned to lead the way. We are an undisputed leader in privileged account security with more than 800 globally and more than 50% of the Fortune 100. We're working with CISOs around the globe to move forward with digital transformation initiatives, some of which people in the audience may be going through now, while minimizing privileged security risk, an easy time to start approaching that. For example, we're currently working with a large global financial institution to provide secret security as a consumable service now to various external decentralized divisions. So as the security team reviewed the applications that were being designed by these teams, it became pretty apparent to them that too many of those required support and automation tools. So each of these automation tools also bring their own approach to managing secrets. And it really starts to slow the velocity of the development organization and create security risks for the enterprise by doing it in that manner. So this particular security team worked with CyberArk to develop an option that was pretty compelling and not locked to a specific tool chain or environment, while still having strong integration points with the mainline tools and platforms that they were utilizing. And it really translated to a win-win for the security and development teams, since the solution was able to achieve twin objectives, right, of improved velocity, but while reducing privileged security risk. So we're going to be talking about all of this today, but more focused on Red Hat's OpenShift container platform and how we can securely provide secrets to application containers running within that container platform. But first and foremost, let's take a quick look at the entire CyberArk solution portfolio, since some of you are new to us. Today, we're going to be focusing on more of the cloud, hybrid cloud-based solution that we provide in the upper right-hand corner under our DevOps and App Secrets Management section. We're going to be touching on CyberArk's Conjur solution today, but we also provide an application identity manager for those of you in the middle of your digital transformation phase who still have some monolithic applications that live on premise and still hold hard-coded credentials that need to be pulled out of that source code. And then on the left is our core privileged access security solution that we provide, and is really the bread and butter and the foundation of CyberArk as a company. It's what we came from and what we built. The enterprise password vault, first and foremost, is our secure digital vault with 7 layers of security applied to it that have been US patented. That's where we hold the keys to the kingdom, we encrypt it, we protect it, we audit access, we make sure authorization is in place, all utilizing role-based access control. And then as we move to the right, we start dealing with how users access endpoints with our privileged session manager, being able to isolate those sessions, but also provide recording and audit on top of the actions taken while they're connected. And then finally, our privileged threat analytics that we run everything through, ingest information not only from our products, but from a SIM or log aggregator that lives in your environment to make true decisions based on things that we are consuming, information that we're consuming through our analytics and processing those. There's a lot more that we do, but at a very high level, that's the base and crux of what we're doing today, but we're going to be more focused on Conjur going forward. So with that in mind, let's talk a little bit about CyberArk Conjur and what it is. Okay, we designed Conjur and aimed it to be the best-in-class user experience for DevOps and those next generation IT environments. And we'll get into that in the next slide a little bit deeper, but we wanted to address a very unique problem that is challenging DevOps teams today, and that's the idea of all of these different secrets that these applications need in order to work together in the same pipeline. We wanted to provide a native integration with cloud management, with platforms as a service, or containerized orchestration tools such as OpenShift, Kubernetes, etc. And just DevOps orchestration tools in general that are used commonly throughout these CI/CD pipelines that Jason touched on very shortly earlier. But at the end of the day, CyberArk is a security-first company, so we're going to always focus on security at an enterprise level, which we do best. So we do support the idea of separation of duties, but we also provide those separation of duties utilizing role-based access controls that we can provide with our solution. Okay, but at the end of the day, we had developers in the back of our mind as we were designing this, because the last thing we want to do is disrupt the velocity of a developer's workflow. So we've designed it to also have an open source companion, so developers don't need to wait for operations or the security team to kick the tires and POC our product, the Enterprise Edition. They can get started securing their secrets today utilizing that open source solution. It is well documented, as well as fully supported by our public Slack channel that our developers hang out in and help everyone work through that stuff. So now, Conjur was built with the idea of personas in mind. And we built an experience for each of those personas. And you can see here on this slide, we've set up these different personas into roles. We have our business owner and security owner in the upper left-hand corner, who typically tend to drive towards user interface, a GUI that they can interact with, that they can get quick and easy information that's relevant to them, and they can move on with their lives, making decisions or investigating forensically, whatever the case may be, based on what the security owner says or sees. So those dashboards are available in there, as well as a user interface. But then as we move to the right, our operations team, our DevOps engineers, typically are running in a terminal, Unix or Nix flavored terminal. They don't really want to leave that terminal. So we've designed a command line interface that they can then utilize in order to interact directly with Conjur and be able to do the same things that our developers can do by utilizing the API. We took an everything as code approach. So our API is fully documented, but also our security policy that is provided as code is as well. This is provided for developers to kind of ease their development against Conjur for automation purposes, but we also provide client libraries for those more popular programming languages that are out there. But finally, and probably most importantly in this whole entire realm, is the auditor, right? How can we trust our automation if we don't have eyes on our automation? And that is where Conjur comes into play and also shines on top of it. Secrets management. Our auditor can be fully self-service, enter the Conjur user interface and get all of the audit information that we've collected on secrets trying to be obtained, permission model changes, etc. So finally, and the final point that I want to make before starting to dive in and talk a little bit about our OpenShift authenticator integration is the idea of security islands. We've been kind of building up to this. We have these different tools with their different ways of managing secrets. You know, Kubernetes secrets. You know, different cloud services have their own ways of managing and encrypting these secrets. Jenkins, Ansible, all of these tools have their own way of storing these secrets securely for you, but they don't communicate with each other at the end of the day. So how are you supposed to fit within the compliance of your enterprise where you should be rotating these privileged accounts, and I'm doing air quotes as I say that, every X amount of days? Well, you can't in this scenario if you want to keep the velocity of your pipeline going forward. You change it one place, it's going to break someplace else because you just rotated that credential. Conjur can resolve this by centralizing that secrets management and acting as a service to each of these tools. So now we're breaking down those walls that are dividing them, and they're utilizing CyberArk's Conjur as a service instead to centrally manage, rotate, deliver, and as well as audit, which is the big thing, all of the access to those secrets. So we've centralized the audit, we've centralized the management. We can easily rotate now because we're delivering these secrets just in time to these tools as they request it. So we looked at Red Hat OpenShift container platform and really wanted to build an integration with it. And the benefits that we saw to utilizing something like OpenShift in order to build this integration is the fact that there's a platform that we can key off of. We'll talk more about that in a second. But our goals for this integration was to securely provide secrets to an application container that's running within OpenShift, okay? We wanted it to be easy to use, so it has to seamlessly integrate with that environment, in which case we're talking OpenShift today. But it also needed to have strong authentication. So we are a security first company. We needed to make sure that this was flawless. So we decided to leverage the Kubernetes API underlying OpenShift to verify the application container identity. And this becomes a very important key as I start to explain the flow a lot more. This gives us the ability now to segregate duties, which is another key integration goal we wanted to achieve. We wanted to be able to provide role-based access, segregation of duties between teams, but also projects within OpenShift as well. And all of this would lead to centralized audit, which is a huge key, as well as the ability to rotate secrets without breaking the application hosted in these containers, hosted in OpenShift, right? Easy integration goals, you would think. So let's take a look at some of the components that are involved here, okay? First and foremost, we have the Conjur master, the brains of the operation, and that's going to be in a Conjur project on the right side, followed by additional pods holding our 2 standbys. Next to that is our application project. Inside the initial pod is going to be the application container. But what we do is we deploy a sidecar proxy with our authenticator container running within it. There's shared storage between that sidecar proxy and that application container, and we install an open source solution that we maintain called Summon. Now what Summon does is it allows us to securely inject into that application container environment variables containing secret values from within Conjur. We'll talk more about how the authorization and the authentication happens in a next slide. But at a very high level, that's what Summon's going to do. It's going to use the identity that it sees local, call to the Conjur master, ask for secrets. If it's authorized to receive them, it will bring it back and then present them to the application container, injecting them as environment variables, okay? But we also have an additional pod in that same project where we have one of our Conjur followers, which is essentially our worker bees, and the authenticator in that pod. That's going to be utilized as somewhat of a service broker between projects. And then we have an additional pod there with an application container in it, no authenticator, sidecar proxy, anything like that. It doesn't need secrets or it's not protected. I don't know, but it's there to show you that, look, everything doesn't need to be set up this way, right? So in a very scalable deployment, we would see it configured like this. I don't want to spend a lot of time on this slide. You could definitely take a screenshot of it if you'd like to dissect it and break it down. But at the end of the day, the key here is the setup of the Conjur cluster. It's set up in a very highly available manner so that if any communication to that master doesn't persist anymore, our followers are still serving your application containers. Those standbys will then promote themselves to a master and take over the job of a master. We create this very highly available because that's what you expect if you're throwing containers and applications into OpenShift. You expect some sort of high availability. But on top of that, utilizing our multiple Conjur files now start to scale out based on load. If there's an increase to secrets needing to be read for any reason, maybe it's Black Friday and you're in a retail business, we can expand out those followers, those worker bees, and scale out to help deal with the load, and then scale back down to the pair at the end of the day. Let's take a look at a more detailed flow of how this works, and you'll start to get a lot of the stuff I was hinting at in previous slides. So first and foremost, like with anything, we need to create a security policy that Conjur is going to follow and abide by. And in this case, we create an application policy where we're setting up apps and services for the cluster, a place for them to live. So we create a layer, and then we grant a host into that layer. And that's it at the end of the day. This is going to be this initial policy. This isn't a production policy, it's an example of a policy. But as you can see, it's written in YAML, so it's human readable as well as easily actionable by machines. So we're gonna load that into the Conjur master now. We'll go ahead and put that in there. So we've loaded the loaded the security policy into the Conjur master. It's now going to be looking for information based off of that anytime it needs to authorize something, okay? So when our pod starts in our application project, it's going to have a sidecar proxy with our authenticator client within it. And it's going to create a certificate signing request. Now, the subject of this certificate signing request is going to contain information regarding the pod that is making the request. So the pod details could be the cluster IP, the pod name, a tag on the pod, whatever the case may be. But at the end of the day, once that is sent over to the Conjur follower and the authenticator, what it's going to do is then verify that the pod exists against the Kubernetes API. So this is very important. We are establishing an identity, a verifiable identity based off of the Kubernetes API. So we're using the platform here to authenticate an identity is in fact correct and true, rather than utilizing an initial bearer token or a secret zero that could be compromised at some point. Okay, very important information there. If that comes back and it says, hey, that pod does exist, it's actually correct, we'll go ahead and sign it and then write it out of band back to that client. Okay, now once that's there, that client will then turn around and then give that back to the follower. Okay, and if that follower then says, okay, everything's good, I can authenticate you now against the Conjur policies that you want the secret for, here's your token. It gets a token back, and it's going to store that token, or decrypt it and then store it in the shared volume. Okay, and then finally, with that token, we can have summon from within the application's container, wrapping that application container, then use that decrypted token in order to call out to the follower, get authorized based off of that token, and then inject those secrets as environment variables into that application container. That's the process at the end of the day in a very detailed workflow. So the benefits that this provides, well, I mean, they're here checked off for you, so we did our work. Simple, context-free, secure method for retrieving credentials. Why is it secure? Well, end-to-end encryption utilizing mutual TLS. But on top of that, we are utilizing SPIFFE-compliant resource identifiers. So that's a very important thing to remember there. If you are dealing with any SPIFFE compliance issues or you need to fall within line with SPIFFE, we've done the work for you from our end as far as authentication and authorization is concerned, which we provide via the Conjur policy, utilizing the signed certificates and also keying off of that internal Kubernetes APIs. But we also provide role-based access control around that. So we can create a role for your operations team, create a role for your dev team, have them gain access to separate secrets, all the while your application is still able to access the secrets that it needs separately. So everybody has their own part to play. Now, the Conjur follower does need to run inside of OpenShift. However, the rest of the cluster, I know in this demonstration, or in the demonstration later, as well as in the slides today, show the Conjur cluster being deployed into its own project within OpenShift. That's not necessary. All we need is a Conjur follower inside OpenShift to work as a service broker. The Conjur cluster, they can then live within OpenShift itself or outside of OpenShift external. We would just need some sort of communication back. But utilizing that follower pair that I had on that detailed architecture diagram is going to provide you with that high availability, as well as the scalability options if that's where you want to go with that. We're able to provide a segregation of duty, which is a huge benefit. We talked about that. I touched on that during the RBAC a couple of points ago. But the key here is that credentials are not exposed at any time to a third party. They only reside in memory. Okay, even the credentials that someone is injecting into that application container are coming across as environment variables. So your developers don't need to hard code their credentials anymore, whether that is in a manifest file that comes in with the code into the container or however that may be, no longer necessary. And then finally, at the end of the day, we're providing a full centralized audit trail that your auditors can then go and utilize our user interface to pull reports on. And I think that's the biggest piece right here, is that monitoring capability, that logging capability on all of the actions that your applications are taking against secrets that we're trying to secure and manage for you inside Conjur. With that, I'm going to give you a couple pieces of homework here. So hopefully you guys will take care of some of this between now and when we eventually do either our DevOps workshop or DevOps security assessment in the future. Go to conjur.org and check out our open source solution, okay? We have a Helm chart that you can easily deploy the open source solution into open source Kubernetes if you're a developer without OpenShift and you're just trying to kick the tires and see what things are about. We also provide other means of easily deploying it, as well as a hosted version that's completely hosted in the back end by us, and we'll create you a 30-day account for you to go and kick the tires without having to deploy it into a Docker host or anything like that on your own. So definitely check that out, but also sign up for our public Slack at the bottom of conjur.org. All of our developers, myself, everyone else on the team, all hangs out in that public Slack lobby to help people get the open source up and running, and we're starting to build a pretty good community there that answers questions pretty quickly. And then finally, we do have a security blog out there at conjur.org/blog, where we are posting up a lot of information, everything from Kubernetes to OpenShift, Jenkins, Ansible, you name it, we've got it, and we're breaking it down and trying to help you secure your secrets and be successful in your security plan while keeping the velocity that you expect by following the DevOps methodology. So with that, I'm going to kick off a demonstration real quick. We'll run through that, and then I'm sure Charlene will have at the end some words for us before we part ways. So let's get started on that demo. All right, well, that demo went well, about as well as one could expect. I feel good about it, but I'm going to kick it off to Charlene now. I definitely appreciate everyone out there in the crowd for sticking it through, listening to my presentation, listening to my demonstration, and watching it. So share it with all of your friends. Hopefully I'll get to do something here on DevOps.com soon, but with that, I kick it over to you, Charlene.
All right, great. Thank you very much, Joe. And I do want to thank both you and Jason for joining me today for a great webinar. I got a ton out of it, and I'm sure the audience got as much out of it as I did. So I do want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, Just know that you'll be receiving a link to the webinar on demand. We're going to be sending out an email to everybody who signed up for the webinar. And in that email, you'll be getting that link. The webinar is actually also going to be living on the DEVOPS.com website. So you can always go there, check it out. Just go to DEVOPS.com, hit the webinars tab. We have both upcoming and ongoing or on-demand webinars there. So you can look in the on-demand section, should be sitting right there waiting for you. While you're on the site, go ahead and take a look around, see maybe if there's any other webinars that pique your interest. But for now, again, Jason and Joe, thank you both for joining me today. And I'd like to thank the audience for joining us today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.